Alright, this is continuing chapter 5, page 124. This is still the nitrogen cycle. So I just want to go through these terms one more time. There's nitrogen fixation, and that's going from N2 gas to ammonia. And that can happen through lightning or more commonly through nitrogen fixing bacteria on the roots of legumes. So legumes are like beans or soy, and so those plants have these root nodules, and there's that nitrogen fixing bacteria is present on those root nodules, and you can see that right here. Nitrification is when nitrifying bacteria convert ammonia, which is NH3, to nitrites and nitrates, and nitrates are the most usable form of nitrogen. Plants really like them. Denitrification is taking those nitrates and putting them back into the atmosphere as N2. Ammonification is when animals, plants die or their waste is being decomposed and it makes ammonia. But that's toxic to aquatic life. Okay, so it's NH3. So this can be bad for aquatic life when it builds up. Assimilation is taking nutrients through roots, which plants do, or eating food, which animals do. So that's assimilation. So some impacts from humans on the nitrogen cycle. The Haber-Bosch process, it actually made synthetic nitrogen possible. So before this, there was a limit on how much nitrogen that we had, and a lot of people think that because they made this synthetic nitrogen, which they first made for a nitrogen bomb during World War II, they were both Germans, but people think that because of them, our population was able to skyrocket as much as it did. And then also burning fossil fuels releases NO2, and that's an air pollutant. When we plant a lot of legumes, we are also putting nitrogen into the soil, and that's not always a bad thing. It's just an impact that we have. Not every impact that we have is going to be bad. It's just going to be an impact. It can be positive sometimes. And then also acid rain. Nitric acid is what is in acid rain. One of the things that's in acid rain. Okay, the phosphorus cycle. So the largest reservoir is rocks and sediments, and this is a nutrient that is not present in the atmosphere. And the phosphorus gets cycled whenever rock is weathered, and that will release phosphorus into the system, and it's going to be a limiting factor. It cannot be synthetic like nitrogen can be made synthetic. It has to be mined. So we mine it from rock, or we harvest it in guano, which is seagull poop. That's how we also used to get most of our nitrogen, from guano, because it has both. But we get our phosphorus now from guano or from bat cave poop. So phosphorus cycle is pretty easy. Producers have phosphorus. They assimilate from the roots into their biomass. Consumers will eat plants, and then when consumers die, then again that phosphorus gets assimilated into the producers when it's decomposed. Mining of guano or manure, that can be added to crops to make them grow more, and then whenever phosphorus is weathered, that also can get into the soil and help producers grow. So some ways that we alter the phosphorus cycle: we use detergents with phosphorus. So detergents can be in soaps, or like the dish soap that we use, or detergent like laundry detergent that can have phosphorus, that can run off into streams and rivers and can cause nutrient pollution or eutrophication. And then that's also something that nitrogen can cause. And then untreated sewage is high in phosphorus as well. It's high in phosphorus, it's high in nitrogen, high in bacteria, and then we use it as a fertilizer. So know several ways to prevent eutrophication on this page. I would definitely know a couple of these because you may have to write them on the AP test. Reducing fertilizer use, but if you're gonna write that, don't just write reduce fertilizer use, but how would you reduce fertilizer use? Okay, so you have to know a little bit more than just that, identifying that bullet point. Know a little bit more. Okay. All right, that's it for chapter 5.